Today we're going to look at GitHub Actions, how to build and test a solution, how to deploy Azure infrastructure, and how to deploy Docker containers. Stay tuned. Lately I've been working on personal solutions I've been packaging, and while I was doing that I thought it might be interesting to share. The thing is, I find that very often the public sample that we have are either too simple or too complex. It's either a little demo with two actions, or it's a business study case where you get mingled in the customer complexity of the project, and it's irrelevant for us. So I found this was a good middle. It tends to be more trivial, but it's not a trivial solution, so it should be interesting. It's an open source solution I'm building. I won't talk about the content of it today, but it's on GitHub. It's open, it's there to see, so we can look at it and you can look at it from your place. First, let's look at the solution. So the application itself is a web application. It runs on Azure App Service Plan, which is a service to run web application. It has three web apps. I'm going to talk about that into a future video, the architecture of the web app itself. But basically, I get a dev, a staging, and a prod web app. It runs containers, so Azure Web App can run containers, and that's what we use here. And it's fronted by Azure Front Door and Azure DNS Zone. I'll talk about it in a future video as well. What I want to focus on today is GitHub. So we use GitHub to, of course, store the code, but also to deploy the application. So I do three things. I build and unit test the code, deploy it to Docker Hub as a container, and deploy it to my web app. Second thing, deploy the Azure infrastructure, and third thing, I deploy to NuGet. So NuGet.org, you might not know about it. It's basically a package manager for .NET. It's very similar to Maven for Java or Conda for Python. It's that type of package manager, and it lives in the cloud. It's a public service. So without further ado, let's look at the GitHub portal where the code lives.
Here's my GitHub repo. You'll notice some code. At the bottom, we see a continuous build / test for dev passing. So we'll see later on what that is for. Let's go at the action at the top tab. We can see I have three actions: package NuGet, continuous build and test, and Azure deploy. This is where the action lives. I can see which one I've run, which one has failed. I can go in the history. I can see all the workflows, or I can go with them separately. So looking at just the package NuGet, for instance. Let's see the definition of the workflows or the GitHub Actions. Go back to code. They basically live in .github/workflows. One of GitHub's signature is its simplicity. As you can see, it's simply YAML files. There's no registration process. It's just we put the files there and they'll get taken care of by the engine. Those are YAML files, very similar to Azure DevOps YAML files. Actually, GitHub Actions are a fork from Azure DevOps YAML files. So hence the similarities.
Let's talk about the philosophical differences between GitHub Actions and Azure DevOps Pipelines. Those are two systems I know very well, so I can compare them. So first, right off the bat, Azure DevOps is more mature in terms of pipeline and delivery. It has artifacts, it has stages, it has approvals. GitHub Actions doesn't have stages at all. It has kind of a sort of an artifact. You have to work hard to get into a type of approval. So Azure DevOps is really a more mature system. Azure DevOps is more specialized. So every time you'll interact with a type or integrate with the system. So you want to compile .NET code, have a .NET task. You want to run some Python code, have a Python task. You want to do some Docker build or something, you do use the Docker task. You have a task for everything. It's very easy to use because you just drop the task in the UI and you specify a couple of properties and off you go. GitHub is very different in that respect because it tends to do everything from the command line, where Azure DevOps will generate the command line instruction to run and will run it for you. GitHub Actions just basically give you access to a bash shell and you write the command you want to run. I find actually it's liberating to do that. So it's a bit counterintuitive, but Very often you're actually constrained by the framework of Azure DevOps. You want to try to do something, and it's very hard, and you're limited to the documentation of Azure DevOps. A reason why Azure DevOps is like that is because, as I mentioned, it used to be based on a UI. Now it's based on YAML, but it carries this legacy around, and because of that, it adds a bit of complexity to Azure. I find that GitHub Actions is not as complete as Azure DevOps, but it is much simpler to understand and to use. Of course, those are my personal preferences. Your opinion might vary. So let's keep looking at the code here.
We want to look at the details of the actions in the workflow. So let's start with the continuous build. We have a name, can be different from the file name, so it can be considered as a display name. You can see the trigger. Trigger is on. In this case, it's on push. So there's different actions you can trigger on. In this case, I trigger on git push, which also get triggered when I do a pull request. And I filter on which branches I want to trigger on. So I trigger on master, staging, and prod. That means that if I have a feature branch or a bug fix branch, the continuous build isn't triggered. That's a design choice. I then have environment variables. Here I have the Docker image name and the resource group. So I prefer to put them in variables if they ever change. Easier, typical variable use. Then I have jobs. I have one job in that workflow. It's the build job. You see it runs on Ubuntu latest. That's the type of VM, can run on Windows, can run on Linux. We see different steps. First step, action/checkout. So I check out the code. This is an optional step. There might be GitHub Actions that don't require any code. For instance, I could have an action that is just about deleting a test environment, that type of things. I wouldn't need to check out anything. Then I set up the .NET Core. This is mandatory because .NET Core is not installed by default. I need to specify the version, so I do that here. It's instructive to see where those actions are coming from. They look like built-in action, makes sense. Like a checkout would be something that everybody would be doing. But actually, those are part of the extensibility model of GitHub. For instance, action/checkout. I go to the actions account in GitHub, checkout repo, and there is the action code for it. In this case, checkout v2. Similarly, for action/setup.net, the code is right here. So we could easily customize, create a new type of action and point to it. Going back, I declare an environment name. Here it's a bash script that I run inline. So I basically have the code of the bash script inline. It's very simple code. I take the current branch that I'm on and I map it to the name of the environment. I then export the name of the environment using this special syntax #set output. So I export the name of the variable so that other steps could use it. I then run a Python script. Won't show you the Python script, but basically what it does, it goes and patches the version. So what I want to do is in a project file, I have the version number of the package. So here's 0.5.5. I want to add the build number to that version when I build the library so that I can keep track of it and I can differentiate two different builds because of their build number. And the build always increases. I run this Python script. I find Python especially useful for that type of file manipulation. And I pass the special environment variable GitHub.run number. I then package my .NET application. I do that in multiple steps. That's best practice to separate steps so it's easier to troubleshoot instead of just doing build that would automatically restore the packages. I do .NET restore separately. So if there's a failure in the restore, I'll know it's because of restore and it won't be part of the build. So restore, build, I run a unit test. I then publish the web app. That's not a publish to Azure. It's just a way of packaging. It's a .NET concept. Then Docker operations. I do a Docker login and I'm using secrets. So let's look at the secrets. If I go back on top of the page, look at settings. If I look at the settings of my project, I get some secrets there. And I see I got Docker login, Docker repo, Docker token. Those are all secrets I entered. I got other ones like service principal ID, secrets, etc. The good thing, those secrets are stored securely. They're encrypted, and I cannot read them. I can update them, and I can remove them because I'm admin. If you go on my GitHub repository, hopefully you won't be able to see them. I cannot see them myself, so that for prevent any leaking. Coming back here, I do a Docker login. There are some custom actions that allow you to do a Docker login. I find them hard to use, and there doesn't seem to be a consensus on which one to use, so I just use the command line. I find that when you do that, you grow up a little, you become more independent, and you're not dependent on those custom tasks anymore. So here, I just log in, I build, I push, and then I tag and I push again. So what do I do here? So if we look at the first push, I push the image and the full version of the package, including the build number. When I tag it, I tag that full version to, if I scroll right, to the name of the environment. So image colon dev, image colon staging, image colon prod. It's akin to using the latest tag in Docker. Some likes it, some don't. I find it useful because you always know what's in staging. Design decision again. So in this case, I tag and then I push again. So in my repository, in the Docker Hub in this case, I have every build number that I built, and I have the corresponding environment. So this one gets overwritten every time. So for instance, dev is always the current. Now, a consequence of doing that, since I don't redeploy my web app telling it to point to the right version, I just point to dev staging prod. I need to restart it, so it's going to reload the Docker image, and this is what I do in the script down there. I do an Azure login, then I go fetch my website and restart the website. And that's it for that workflow. Pretty simple.
Let me talk about environments. So GitHub Actions do not have the concept of stages like Azure DevOps do, where you build something once and you deploy it to dev, staging, prod. You might do something in between, but that's the you always deploy the same artifact. A GitHub Action workflow is something self-contained. It starts from the top, goes to the bottom, and that's it. It doesn't share something between different workflows. So how do you implement environments where you want to wait, you don't want to deploy from dev to prod in one shot? Actually, I did have to ask myself that question. And if you have a better answer, please share with me in comments down below. But the approach that I took is to basically promote branches. With GitHub, what I do is that I have a branch for environment. So let's look at it actually. So I have a master branch. This is where I do my development. This is where I introduce features. So I might have a feature branch that goes on top of it. So the master branch is a bit more stable. I develop the feature, merge it back with the master branch. Then I have maybe fixes, same thing. But then I have a staging branch that branches off the masters. And when I want to promote something from dev to staging, I simply do a git merge from master to staging, and it triggers build automatically and build and deploy. And same thing for production. So now might ask, how do I deal with bugs? So I don't want to, since master is this ever going, evergreen, very unstable, potentially branch. What I do is I might do hot fixes on the staging branch, test them in staging, propagate them to prod, and propagate them back to master as well. So I don't know, it might look like a Git flow type of process. I never worked with Git flow, but this is how I make it work.
We'll quickly look at the infrastructure one. Very similar. Triggers on push, on the branch master only. But I go further down, I filter on the path. So I just want to be triggered when some files are modified in a git push. So there are two files. There's that actual YAML file. So if I change the workflow, I want to run it again. That makes sense. And also the ARM template, the JSON file. And that's it. If anything else, if the code changes or anything, I don't redeploy the entire infrastructure. So that way, this thing doesn't run all the time when any commits is done. Declares environment variable, job, deploy. Then I have two simple steps, an Azure login, an Azure deploy that I do via bash script. It's very simply an Azure deploy. That's it. Finally, the NuGet push. This one is a bit different. It's not trigger on push, it's trigger on workflow dispatch. What is workflow dispatch? I got no idea why we chose that name, but it's basically a manual trigger. So it's when a user decides to trigger an action. Because it's a manual run of the workflow, I can take parameters because the user is interacting with the environment. So in this case, I take the alpha parameter. So it's a way to decide if I publish an alpha package or not an alpha package, deciding on the stats of that. And I go again, doing a checkout, setting the .NET Core, installing the dependency, so .NET restore, patching the version again. So you see, I have to redo the same steps because I cannot build on the artifact of another action. So that's the drawback of having GitHub always self-contained into one workflow. I finally do a publish NuGet using the NuGet CLI that's installed by default when you install .NET, and using the secret to publish the API. And that's it. If we look at how I would trigger that workflow. So if we look at the other workflow, you see over there. So just to make sure we have a create status badge here. This points to the image that we saw, the image that says if the build is passed or not. So you can put that on your readme.md, and that gives you this little image. Just wanted to mention that. Azure's deploy similar, but if we look at package NuGet, I now have this run workflow because it's a workflow dispatch, manually triggered workflow. I can run it, and I can input my version here and run the workflow.
All right, this was GitHub Actions workflow. I hope you find something interesting in there and you learned something today. I invite you to go to my GitHub site, look at the workflow that I authored, and look at the documentation as well, the online documentation. Both links are down below. To summarize, we looked at 3 workflows. One workflow, which is the one I use all the time, is triggered automatically, is the auto build, auto test workflow. There's in each branch. We look at the Azure deployment, so deploying the Azure infrastructure. And finally, we look at the NuGet package. So that's an example of something you might want to trigger manually once in a while. A word about security, you might have noticed I show you all of that. It's on GitHub, it's public. I don't fear showing you that. Part of it because it's not Pentagon secret. If you ever hack it, my life won't be in shambles. But also, it's a very secure platform. With the secrets, it's a good dichotomy where you got the workflow is public, but the secrets are not. And this would distinguish this thing from the actual code to deploy into my actual Azure subscription. So I find the platform quite secure, and it's quite nice to collaborate in the open and do open source development. My general feedback on GitHub Action, I think it's really good. I quite like it, as I mentioned. Personally, I prefer it to Azure DevOps, personal preference. I find the platform is pretty fast, like the provisioning of VMs or agents or whatever they're using in the backend to do builds is relatively quick. In general, the documentation would need a bit more love. It's not always obvious. There's not tons of examples, and the search could be improved. But otherwise, a very nice platform, and there's a lot of momentum behind it. It's quite new, and it's already pretty good. So I can imagine that it will evolve. It has a good future in front of it. Call to action, as I mentioned, go to my GitHub site, look at it, look at the documentation. Try it today, try it on your site. Even if you're like me, I was before, I was having GitHub repository for the code, but I was using Azure DevOps to do the actual build. You can try that on GitHub. You can try GitHub Action today. Just have a feel of it. You can build whatever you want. All right. If you have any questions or comments, leave them down below. Otherwise, I'll see you next time.